So then the next thing we're going to do is solution stoichiometry. So we are going to combine calculations involving molarity with stoichiometry. So here's our formula. One important property of oxalic acid, which is my H2C2O4, is its ability to remove rust, which is my iron 3 oxide, right? According to this reaction. So my rust reacts with my oxalic acid to produce hydrogen ions, whatever the guy is going to be called, and water. We are going to calculate the molarity, so the concentration of the oxalic acid solution, if 250 milliliters of the solution was required to remove 10 grams of rust. So we know that we have 10 grams of the rust. We know that we have a volume of 0.2500 liters of oxalic acid, and we want to know the molarity. So what do we have to determine first? Well, we need to know the moles of oxalic acid. So we're going to start with our 10 grams of our rust. So 10.0 grams of the Fe2O3. And we're going to calculate the number of moles that is. So we're going to say that 1 mole of the iron 3 oxide weighs what? So we calculated this on a previous page, but we'll just write it again. So there's 2 irons, which are 55.85, and there's 3 oxygens, which are 16. And that would get me the moles of iron 3 oxide, or of my rust. And now what I would want to do is convert that to moles of oxalic acid. So then we know that 1 mole, always check that your equation is balanced, but they did balance it for us. So 1 mole of the iron 3 oxide produces or needs 6 moles of the oxalic acid. And then we're going to plug that into our calculator. So I'm going to put in 10 divided by bracket 2 times 55.85 plus 3 times 16 unbracket times 6. And I don't need to divide by 1, but that ends up with 0.375704 ... Again, this is not a final answer. This is moles of oxalic acid. And then what we're going to do is take these moles and then find the, what do you call it? Molarity of the oxalic acid. So I'm going to do it as another calculation. You could have just kept going and said, okay, well, I now want to go moles per liter, and you could have just put the liters down here, but I'm going to do it as a separate calculation and say that I'm going to calculate the molarity of H2C2O4, or oxalic acid, or maybe instead of putting molarity, I'm just going to put concentration. So the concentration of oxalic acid will equal that answer that I just got, unrounded, divided by the volume of the oxalic acid, which is the 0.2500. And then I would get to, how many sig figs? 3. So I would get 1.50 moles per liter, or molarity. So the concentration of the oxalic acid that I would need to remove 10 grams of rust would be 1.50 molar.